introduce like how to build a zkDApp and what's zkDApp. Right? Let's build with like Oracle to build a zkDApp. So before we go into zkDApp, we need to have the concept of what's zkOracle. So zkOracle essentially is like, for Ethereum at least, is this structure that we have like the consensus proof, and we have the proof for the event, and proof of the state, and proof of transaction, and also enable custom compute for the verifiable custom compute in the zkVM. So basically, HyperOracle can unlock this following ability for the superpower for the smart contract. For instance, you can have like a historical on-chain data for your smart contract with HyperOracle. And also you can have like complex compute extension for HyperOracle to use in your smart contract. And also have like, you can have a multiple data source. In the future, we can support like internet data source for your smart contract too. So HyperOracle is a programmable zkOracle protocol. So what's zkDApp? zkDApp essentially is the instantiation, the instant of the intent compute. So if you want to have an intent DApp, what you're talking about most likely is like the zkDApp. So zkDApp is a DApp that utilizes the zkOracle to perform the computation and the data fetching. So with HyperOracle, we are empowering the next wave of the zkDApp, which will be novel, secure, and permissionless. And also, it's really easy to build with HyperOracle to build a zkDApp. There's a many usage for zkOracle in your smart contract. The first will be like the bunch like new DeFi usage, like zkAMM and kind of like a fully on-chain derivative and fully on-chain ETF. And also we have like enable AI GCNFT for a zkOracle. You can also perform some little bit like ML inference. We will talk about it later. And also can have a zk automation for recursive payment and some schedule on-chain ability. Here is the study case for what we can do with the zkOracle. So let's go back, review the history for the development for the DeFi. So in the DeFi 1.0, we have the centralized exchange that like we have like ERC20 that like we can issue any tokenize everyone and organization entity on chain, but we only can do the swapping in a centralized exchange. So that's why we have a DeFi 2.0 AMM that will enable people to generate the token, tokenize themselves, organization on chain, and also swap the token and provide the liquidity on chain. And, but we still have another problem is that we cannot have the derivative that the underlying asset is that certain token fully on chain. What's the problem? The problem is because like it would be really expensive on the gas fee if you put the whole derivative condition checking on chain and automation on chain in DeFi 2.0. So that's why we introduced like the zkOracle to have the zk automation for the DeFi 3.0 that will enable like fully on-chain derivative and like fully on-chain ETF. For instance, before you have a zkOracle, the only way you can do a fully on-chain derivative is that you have a smart contract on-chain, and then you do the triggering for the smart contract every block to check if fit the condition for the clearance. For instance, I want to short the ETH to the half of the price we have today, and then what we need to do is that you need to call the smart contract every block, and then check if the ETH price is like the half of what it hit the strike price or not. But with the zkOracle, you no longer need to check it every block. You can just basically like have the automation and only call the smart contract when you need to call the smart contract. And why building with zkOracle is better than the traditional Oracle is because like it's safer, faster, and more decentralized. The Oracle we use today, most likely like channeling type of Oracle, is like pretty centralized and pretty inefficient and manipulatable. So the way the workflow for traditional Oracle we have today is basically you aggregate all the computation result and data fetching into some certain like centralized cloud node, and then report them into a smart contract through this trusted entity. And by this way, like all the people need to stay, all the Oracle node need to state the certain token into the Oracle node to ensure their computation integrity. And then with the zkOracle, we no longer need to require the Oracle node to state the token to ensure the integrity. Instead, we just use cryptography to ensure the computation security and data fetching integrity. And then use the smart contract to verify instead of trust to do the data fetching and computation extension. So here is the comparison between the staking oracle that we use today and the zk oracle that we are going to use in the future. It's a paradigm shifting. So we can tell that like traditional oracle can finalize the thing that require 1 to 2 minutes to finalize a data and computation result, when zk oracle can finalize that within 12 seconds, which is the Ethereum block time. And we already have the benchmark today. And the way we keep the Oracle network fully decentralized is the idea we call it proof of Oracle work. So what is the proof of Oracle work? And how are we gonna keep the Oracle network become fully decentralized and like censorship receipt? So it's the whole procedure, the workflow for the proof of Oracle work is that the developer will put down the bounty for the computation task that they want the zk oracle to compute with for their smart contract. In this case, this guy want to compute a Black-Scholes model for his smart contract. There's a multiple reason why smart contract cannot do Black-Scholes model. For instance, the square root, the log method, and like the distribution computation, this mathematical statistic computation. And so smart contract cannot do that. So that's why we need zk oracle to do that. But we can send out the signal through the smart contract, say, hey, I want to do this computation, and I think this job worth like 5 token or 1 ETH for this job for my smart contract every block. Probably it's too expensive, probably like 0.01 ETH per block to do the computation for my smart contract. And then the developer will put down the bounty in the zk graph bounty. And then all the zk oracle node will compete with each other to finish the computation first and submit the proof first into the verifier smart contract, so that the smart contract can check if the result is correct or not. After it passes the verification in the smart contract, it will transpass the result into the target smart contract that developer want to be triggered, and also transfer the computation result into. So I'm going to introduce this like zk Graph Studio, which is a web IDE that can help developer to develop a zkDApp within the afternoon. That's the purpose for this hacker house, that like to make it more detailed. So if you guys have any question for how to make a zk graph for a zk oracle that you want to program with, you can ask our expert. Su Ning is here to check about more of the technical detail. So basically, this is like the zk Graph Studio is essentially equal to like a remix for Solidity that will enable developer to program a zk oracle in a website that they don't need to spend time on figure out the dependency and stuff. Basically, a senior Solidity developer can develop a zkDApp within an afternoon without knowing anything about zero-knowledge proof. So there's a many use case for zk oracle, and so like many use case. Like the one I mentioned earlier is like the DeFi 3.0 use case that's like fully on-chain ETF, fully on-chain derivative. And also you can have like some use case like a security use case, like a 0x hack, that basically utilize the zk oracle to do the security check for a smart contract. And if like the hacker can hack a smart contract successfully, but he can propose a bounty into the protocol to say, hey, I hacked your protocol. If you pay me certain amount of money, I will review that and not execute this certain hacking behavior. But if you're not, they're going to utilize the zk oracle to do the hacking by themselves. Okay, and so basically it's like a negotiable protocol for hacker. And there's a new usage like zk stablecoin that's like fully on chain with 100% collateral, and also have like some DAO management for their smart contract, like ELS use the zk oracle to basically manage the DAO for voting result, because they pretty often need the voting result every block. And and also, what's more than a zk oracle with building with Hyper Oracle is that we propose a new mechanism, and the library is open source already, and it's already enable Stable Diffusion, Llama, and ChatGPT on chain. And this is called OPML. And this OPML library you can check out in Hyper Oracle repo, and can utilize that to build something cool with like this if supported model, so you can have the model result on chain. Compared with zkML, the good thing for OPML is that essentially we can do any kind of model as long as you can run in a computer for the inference. You can have that for your smart contract. And but I would say the problem for OPML today is like in the most ideal situation that we have zk fraud proof for the OPML, we will still need 2 block time to finalize the ML inference result into a smart contract. And also the gas fee is a little bit too high right now without zk fraud proof. But we are working on it. If you want to try out how to put a on-chain machine learning, this will be the best library you can check right now in the market, I think. Thank you. Here is like Discord. Please join our community through the link. You can also check out our progress in GitHub and follow us in Twitter. Yeah, basically that's it.
The most interesting use case you've seen people developing on Hyper so far?
Yeah, I would say like the fully on-chain derivative guy. Like he basically built a repo that called decentralized ETF right now. So what they do is like they want to put the SP500 fully on chain. Basically, it's like have like top 50 most traded ERC20 token in the DEX, and then this smart contract only do one thing and one thing only. That is like act like SP500. So he just like SP500 essentially what it does is like he purchased like the most representative 500 stock in the US stock market. They will change their holding every 3 months. So what this like decentralized ETF does is basically they will use like a algorithm that hosts inside zk Oracle, and then they monitor all the on-chain behavior they want to monitor, and then pick out the most representative top 50 ERC20 token, and then that smart contract do only one thing and one thing only. It's just like holding them, and then change that in every 1,000 block. And every 1,000 block, they will repeat the most representative top 50 token. It's like, and this smart contract, the most amazing thing is like, doesn't have an owner or at the main. So which means like nobody can change it, and it's really neutral. Once they put it on chain, like nobody can change that. And the way he utilized, so before you cannot do that because like you need some monitor to keep like checking out what's the most traded token pair on chain. But like it's like trusted entity to do it. So which means like the smart contract need a super user. But right now we don't need a super user for the smart contract to do that. You just have verifier that asking the data from a zk Oracle and then refresh the smart contract every 1,000 block. And then that will have like fully on-chain and neutral asset management smart contract. And I think in the future people, if they don't want to be hustled on DeFi, they can just like buy this like decentralized ETF and put down their ETH in it, and then it will management for them automatically. Because like in long run and or in a big size for the capital, normally the passive ETF is like always outrun majority proactive fund in the traditional finance market. So I think it's pretty common in this phenomena. So I think it's going to be pretty useful for everyone here who actually use DeFi, right? Yeah.
You mentioned you have some use case, like there was some security.
Yeah.
Security. So what do you use? What do they use of the Oracle to check the smart contract?
So what they do is that they have like a state checking thing inside zk Oracle. So basically what they do is that we run a smart contract inside a zk Oracle and run to basically essential idea is that they try to prove that I'm able to hack your protocol by running the EVM logic inside the zk Oracle. And then I can prove that in the next block, if I implement this logic, you will lose all your fund in your smart contract. At least majority of the fund, the state slot will be changed to like a really low amount of the money inside this smart contract. And then, which means that I already had your smart contract and transfer the fund out to my smart contract. But I didn't actually implement it because like this all running in the simulation inside zk Oracle. But you generate the proof without revealing what's the problem, what's the buggy point for your smart contract. And then I will submit the proof, and with the state of basically the public input is that the state of the how much money you left in your smart contract, and then with the proof, and then submit into the smart contract that can verify that show the guy hacked your protocol, but you don't know how he hacked it. So this like protocol will enable the protocol side to provide them a window for negotiate with the hacker. If they pay certain amount of money, probably it's like 1% of the governance token into the deposit into the hacker's wallet, and they will not execute this thing and reveal what's the problem to the protocol.
It's like alternative of the white hat bug bounty, but in a not very present way.
Yeah. It's more like a hostile version for the white hat bounty thing.
Yeah.
But it's a real world, right? Like hacker normally do not care like white hat bounty thing because they're hacker. What they want to do is the maximum their profit. But in the real world, even though you try to watch the money that you hack from certain protocol, but you still have like risk that you got caught, right? So, but if you submit this thing as the trade for certain governance token and cash them out, that will be considered as clean money. Nobody will after you. So it's like expectation value here that's like need the people to negotiate and have a game theory behind them. But it's like pretty early stage project, but it's like really innovative.
This is your own project or is this somebody?
No, it's somebody else. Actually, it's like a team in Hong Kong doing that. It's not even like we don't even know them before
So
they
haven't been applied yet.
Yeah, it's not. It's like they have a zkDApp hosting in September 1st that try to use this thing to find out who is the hacker, can hack what kind of protocol.
Okay.
Yeah, they're doing it and it's progressing really well.
Yeah, that could be very interesting.
Yeah, it's like security usage. And yeah, we have like AIG's usage, DeFi usage, security usage, and DAO management. And I think that's like most common usage for now.
Yeah. Cool.
And what's most important that is like you can already build this thing out today, because like I know a lot of another like similar project that they are still in under development, but with Hyper Oracle you can already build it today within an afternoon. That's like what's our advantage and why to choose us to build with.
In your Oracle architecture, there was one page like showing
Yeah.
how the Oracle works. It's like you have this bounty,
Yeah.
like to have someone to maintain that work. But right now, is that also related with this OPML? Is that same thing or different?
No, that is like basically how we keep the Oracle network alive. So it's like, proof of work, right? Proof of work is like bring two things to Bitcoin. One is the consensus. That random number can summarize all the transaction in that certain block. And the second thing it bring to the Bitcoin is like the liveness for the network.
Yeah.
Because like there's a reward for every block. Like right now it's like it's like 25 Bitcoin, right? Yeah, something like that per block. And so, which means like, it's not 25, it's like 0.25 Bitcoin per block. And it's like a reward there. People will spend the resources to do the computation for this certain network. So it's the same thing. Basically, like this zk Oracle network or no operator, they can download image like for free, it's open source, and then they can run it. And then use the computation to compete for the computation job that hosting inside the smart contract. If they are, for instance, this job, I want to do a normal distribution for Uniswap trading pair between ETH and USDC. I want to do the normal distribution for all the transaction. And I do the computation, and then I put down I want people to do the computation for it. And I put down how much it costs, how much I think this job value is. For instance, Uniswap, like this project put down like 0.1 ETH for every block who compute this thing for me. And then all the zk Oracle is competing to finish this job and the proof first for that 0.1 ETH. Yeah. And whoever.
The one before.
Yeah, the one before.
Yeah, the Oracle, how does the Oracle work? Yeah,
this one, proof of Oracle work. Yeah, so basically all the zk Oracle are competing for this certain bounty. For instance, in this case, this guy, developer, they put.
How many nodes do you have?
It's dynamic. It's dynamic. Yeah, it's dynamic. It's basically.
So in the beginning, maybe mostly like the one you know.
Yeah, I think right now we don't run our own node. Yeah. It's just like all another people, partners are running the nodes. Like it's permissionless. Everybody can run the node. And when we have it in mainnet, everybody can run the node. And whoever run the node will get the token reward for this like whatever the job we put down.
Yeah.
So
how you token have been.
Yeah, have the utilization. Yeah, it's a utility for the token.
Yeah.
And so whoever passed the verification first, who will get the reward. And we don't need to worry about the front running here, because like one of the.
But how do you prove that they give the right result? Is there some?
It's a smart contract verifier. So if you are having.
It's like automation too. You already have.
Yeah. It's like customized automation that you can write anything in it and then get verified in a smart contract.
But I have a little bit concern on that because the scope might be quite diverse from each other.
It does not matter as long as it's because it's a tooling complete system.
Okay.
So like no matter what we write, you can prove that in a smart contract anyway. And so the core thing is in here is that like how to prevent a front running for like, because I have 5 guys here, and then I finish the proof first, and I submit the proof with the result into the main proof, and how I ensure my transaction got taken, and you are not paying extra gas to front run my transaction into the verifier, right? That will be the problem. So that's why we have creatively invent a new type of circuit for signature for the public address. So which means like in your proof, you also including your wallet information. Even there's another guy paying extra gas to try to front run your proof with the result, you still receive the money in that certain address instead of this front runner's address. So this is like some little bit like innovation we have here to make this whole system work out.
Yeah, my concern will still be the circle, that if that can be general or.
Yeah.
Yeah.
The circle.
Yeah, I mean the circle itself is still like going to be a general treated with all the problems.
The circuit or
the circuit.
Yeah.
Okay, sorry.
Yeah. We utilize zkVM, so you have different circuit every time. So, but like for instance, today we have 5 different computation jobs. One guy want to do a square root, one guy want to do a floating point, another guy want to do a normal distribution, another guy want to do a Python distribution, and so we have got 5 different verifier in here, and then so different computation jobs have their own verifier in the first version, but in the future version, like probably in 1 year from now, we have a unified verifier that can support all the verification in one certain verifier. That will be another type of thing in the future. But right now, like all verifier all computation tasks have their own verifier in the smart contract.
That with their own scope.
With their own scope only, yeah.
Yeah, because that's also quite limited towards the development of the zkEM. Because they are maybe not the super for general. They're still pretty certain circles to work. So it's not dealing with all the new thing. You know what I mean? If they have something out of this 5 scope, they have something totally new.
As long as your computation scheme are the same, it will be the same verifier.
Okay.
If you have different input, for instance, this like normal distribution have like 1 to 10, another one have like 2 to 20. It won't affect. It doesn't matter. It's just different input for the same circuit.
Okay.
So it's the same thing. So we don't need to worry about that as long as this DeFi protocol have certain what they want in the verifier. So they can use the zk Oracle to do that. And the reason why it's like permissionless and censorship receipt or like decentralized is just simply because like the proof of Oracle work is like decentralized. Everybody can run a zk Oracle, so nobody can stop any job to be executed on chain. As long as we decentralize enough, like there's a job like that U.S. government or any authority try to ban it, and there's another guy in another place in the universe, on the earth, will do it in the zk Oracle. It's like it still work out because it has the bounty. It's just the same logic that why Bitcoin is decentralized.
And then how efficient it will be? You say something after 1,000 blocks or something?
No. So that's the use case. Like
okay.
The use case, they choose 1,000 block to update it.
Yeah.
But like normally, you can do it every block. It's just up to your demand. What kind of usage? If you can make money with like every block and still do verification every block, you can make money from it.
Which
Why
chain
not?
you're using now right now?
Right now we just support Ethereum, just for now. Yeah.
Okay.
It's fast enough right now. Our benchmark is like 7 to 8 seconds for all the computation tasks that are happening inside zk graph. Yeah. So that's yeah. Any other question?
Beautiful.
Yeah.
I guess we can collect. Thank you, Kartin.
Yeah. Thank you.